Okay, so your lab write-up this week is really, really small. We're going to add gravity to the game that we're building. Um, and we're going to apply gravity to all movable objects. So we need to talk a little bit about gravity. So when we think about gravity, we're thinking of a force coming straight down. And that's more. Let me jump into paint. This will make more sense. So we're thinking of here is the ground, and gravity is a force pulling us down towards the ground. That's a very simple view of what we're doing because gravity plays on a big grand scale. All right, that's because the floor is level, and basically we're playing on something that where the floor is level. In reality, if this is the Earth and we are here, then gravity is in this direction. But if we are here, gravity is in this direction. So it is if this is our center. So basically, those vectors are generated by the center point, and that's kind of where again I want to get across. We talk about gravity is like 9.2 meters per second, but that's given at sea level. If we're in Denver, that's not the value of gravity. I actually don't know. I don't know what that would be, but it'd be as much. Denver is a mile above sea level. There's a difference between the force of gravity there is much less. When the Olympics went to Mexico City, Mexico City is it's about just as high as, if not higher. It's in that we're above like a kilometer to a mile above sea level. And one of the things about the Mexican Olympic Games was that long jump, high jump, there were there were better chances of doing world records then because the force of gravity, because there was less gravity, there was less um there was less and as you go up, the other factor is there's less air effectively, so the air resistance was less. So there were factors there that made it um make it easier to basically do those higher values. So we're gonna start basically like we're gonna go through and basically do the basic infrastructure pieces, basically making sure that one of the things that I did put in was a list for movable objects, and if a movable object is being spawned, it should be put into that list effectively. um so what we're going to do is at every frame we're literally going to go through, we're going to add some sort of gravitational pull. For our purposes, the center of gravity is going to be the center of our screen. So it's going to be at the grid space of 0, 0. And that's the other thing that we'll need to do, as well as we'll add a Boolean where that is active. So um, what this means is that as if you were moving in this direction, I'm going to do your vector of gravity is going to change. And that's something that and so that's something to keep in account, is that as you are moving around the center, effectively your gravity is going to be being changed. So let's jump in. So that these are the and this is, again, gravity is a force that's being applied. In theory, you have a gravitational pull. It's small, it's very weak. Um, yeah, I mean, we're now getting into like there's Newtonian physics. And I want to be clear, we're talking about Newtonian physics here. We're not talking about quantum mechanics. because quantum mechanics is dealing with things at very small levels.
We're not getting that small.
We're not getting that small.
We're at apple fell off the tree.
Yeah, we're only at apple fell tree. Yeah, when we get to that level of there's a video of a lecturer who's introducing students to a class on quantum mechanics, and basically by the end of that next week, he tells them that no one really knows what quantum mechanics is, and by the end of the week, you will also not understand what quantum mechanics is as well. So that's the joke there. So we're not dealing with quantum mechanics. We're dealing with Newtonian physics here, and we're only dealing at that level of simulation here. Not to just be clear. We're also not dealing with anything with Einstein. So relativity is not coming into play. So we could be zooming across 0.10 of speed of light. In theory, time is slowing down for that object. Well, it is slowing down for that object. That time slows down for that object. So what would take, and this gets back to, if you've seen Interstellar, they get close to a black hole, and as they are on that planet, they're there for about like an hour in their time. When they come back, it's been 4 years for the person who's been on the command module, effectively, and it's been many more years by the time they get back to Earth. So that we're not dealing with any of those relatively. We're just time. We're not dealing with any of those factors. So I just want to just try to get a scope of what we're playing with right now. All right, let's.
TLDR, gravity pulls you down. Period.
What comes up must come down.
No, see, here's the problem. That's one of the first things that so Jacob, you just fell into the first trap. What is down? Like for us, gravity, if we feel to the floor. But that's because we are on a point on the Earth. For us, what we need to do here is, in terms of the simulation here, is that we have to figure out what is the vector from the center, where the origin of gravity is going to be, which is going to be the center of the screen for our purposes. And I'm going to I'll put a circle to be the planet for our intents and purposes.
That's what we're doing. Okay.
Yeah, this is what we're doing. So basically, effectively, what we're doing is basically we're effectively putting a planet into play that will have a gravitational pull. Where is here? Where's the space? There we go.
So basically, like the Mario Galaxy kind of gravity.
Yep. Yeah. So as we go around objects, that gravity is going to pull us with a different vector.
And like if you get close enough to another planet, you'll get pulled into there.
Yeah, we're not playing with multiple planets. This is. I mean, like if you want to play with that type of physics, like Angry Birds Space, for example, has this type of physics where they have multiple gravities and they have different gravity. And and one of the things that's interesting about Angry Birds Space is that planets have a radius which the pull starts to come into play. We're not playing with any of that at this moment. All right, let's just jump into our spacewalk grid.
I'm just saying, along with the whole like first trap of what is down. Down could be anywhere.
That could be up.
All right, so I'm gonna set up. Let me see. Where's the magic circle? All right. And I'm just gonna, for sake of argument, I'm gonna make a planet circle. I'll make it green just because why not? Actually, I'll make it blue. No, I'll make it green. It'll stand out. I give it a radius 20 for right now. Just I'll do 15. Nah, 20. We'll do 20. The ships are about 10 size, so yeah. With that in mind, let's put the so we know. What was the magic? So I know I want you to be. Let's set these at 100 units. 100, negative 100, and this will be negative 100. All right. So for our purposes, the moving object, so we've got this moving object list. So I've got a list of objects that are intended to be, that are moving. So when you, again, one of the big things is when you spawn the missile, right now, basically, when you spawn, make sure that you're getting into the moving object list. All right, so let's jump back in. So we'll just show where we are setting up right now. Oh, and what did I do? Oh, I set the sides to 20. 360. I'll do 36. And this will be 20. There we go. So here is effectively the planet for our intensive purposes. All right. So we got that up and going now. All right, let's get into so here is we have okay, so actually I want to go up to my booleans. Do I have any booleans here yet? Yeah, I'm gonna put a public bool gravity is equal to true. I should say is applying gravity. I'm going to jump into the tick, and I'm going to basically, again, it's going to basically, hey, handle input. And then I'm going to say apply. So if is not apply. So, simply put, if we're not applying gravity, we're just going to return, not do anything. So this is something we can turn off, turn on. In fact, one of the things we should in fact, what we want, I'll go in right here and do a bool. want to do is F3 key, keyboard. Let's press this frame. Go down if F3 key. Is applying gravity is equal to so basically I can flip this on and off. So and that's something you should have in your application. I will probably go back and add that. Hey, have a key to turn on and off gravity in the application. Let's jump back. Okay. So literally it is, so we are going to do, I'm going to put a variable here for right now. I'm going to move it later on, but it's going to be a public float force of gravity. I'm going to do 2.5. We'll see how this is a value to play with. Play with what, you know, do as you see fit, as you, you know, I'm going to do a version here. You might find gravity higher is better. Gravity lower might be better. You might have multiple different versions of different values of gravity. You know, in fact, you could do force of gravity equals 0. One of the things you do is if force of gravity equals 0, that would turn off gravity. What you don't want to do is a force of gravity of like -1. Because that will push, that essentially is now pushing it away. Extra credit, make a list of different gravity values and play with that. -1 being the one that pushes, yeah, definitely put a -1 and see what happens. But for our purposes right now, we're going to start with 2.5. And that's going to be something like 2.5. This is going to be units per second. So we're going to have to multiply that by time.delta time to effectively apply that correctly. So this is again a for each. Actually, I don't want to use var. This is moving object item. We'll use the word item. I can't think of, but we know that item has its velocity, and that is basically item. So this is what we're going to affect. What we need to do is figure out the vector where this is coming from. So essentially it's going to be, I'm trying to think. It's essentially the direction vector. Which is going to be the vector 3 so equal to the so it's going to be the item position normalized. We are getting away with a minus b sorry, without doing A minus B because B is at 0. So this is just a simplification. So normally we do A minus B, where we are minus where we want to go. That essentially is where, I'm sorry, I may have it back. I have it backwards. It's B minus A. And it's going to be the negative value. So because B is 0, we don't have to worry about that subtraction, but it's still A is negative, but we need to normalize it. And then we can then the item velocity, we're going to the direction vector times force of gravity. Oh, and that's going to be times time dot delta time. Just to simplify things, just this is a simple optimization. So basically, I'm not creating the same variable over and over again. I'm just going to grab. I'm reusing the same variable over again rather than recreating it. So less overhead in terms of this. It's small, but if we were doing with thousands of objects, this would come into play. So this is a small. So it's a small optimization to use the same variable location rather than making multiple new variables. Essentially, I think this should be it. I did start it with true, right? Yeah. Okay. And this is again should do what we want. I mean, one of the things that you could go in here is that as closer you get to the planet, like the closer you get to it, the stronger gravity is. So there's lots and lots of things that you can do to play with this. Let's just jump in. And you can see they are coming in closer. Now, I don't have any collision between the two ships, but you can see that they accelerated out and they're coming. So they're basically getting pulled back in. So they're accelerating in. So let's jump in. Let's make this. Let's make this 3 times stronger. I actually need to go in here and assign the value here now. And I want to make it stronger. Come on. All right. Let's jump in at the missiles. Move speed. Let's cut this in half. You can starting to see the missile arc. Let's cut that in. Let's cut that down to just 50. probably need to go a little bit slower. Let's go at 30. And then I know I'm launching it at.
Is the acceleration taking into account the max speed of the ships? Or is that a separate thing?
It is accounting in the max speed of the ships.
Okay.
But let me see. Let's go to. I mean, I've set it to the max ship velocity to 250, which is huge. Let's look at the missile. Let's go. Let's grab this. So I'm gonna use the same max velocity. So we can get really high velocities if we do this correctly now. Move speed to 30. I'm gonna have to look at the moving object. Oh wow. Never mind. Let me take these out. I said default value of 2000. There we go. There we go. Where's the missile? So I'm launching the missile at 25 degrees. I'm just gonna set it to a 0 degree. Take those 2 lines of code out. And I'll bring this in to 70. Yeah, I'll do 60. I'll bring it a little bit closer. You can see that you can see gravity now pulling at it. And I think I gave it just enough velocity to hit the other ship. Let's, for argument right now, do 35. So the goal, what I'm trying to do is get it to like try and circulate around. I may have to. It's gonna hit the ship again. So what I need to do with the ships. Let's see. Spaceport grid. Actually, let's keep it at 100. Let's bring these into 50. There we go. Okay, should stay outside of the So you can see now that that I basically gravity is keeping this in a. I gave it enough forward force, that as gravity pulling it down, it's keeping its forward direction. It's keeping an orbital direction. It might be decaying a little bit, but that's okay. Yeah, it's decayed a little bit more. Or does it feel like it is? I have to draw. I have to build something to draw the line that it's moving on. But here is gravity in a nutshell. Things to do. I'm definitely going to put in extra credit. Gravity has what's the best way to put this? The planet has collision. So if you touch the planet, you're effectively dying. This is again, you'll need to, and that's a gameplay feature. Yeah, I mean, like basically, there were 4 options in the original game, Space War clone. It was: is player 1 a bot? Is player 2 a bot? Do you have gravity on, and do you have the planet on? You can have the planet without gravity. You can have the planet with gravity. You can have the without the planet and have gravity. So it gave you essentially different spheres of operation. And here we're on our way to. We got dynamic motion. Again, the player's thrust should be able to break gravity. That's one of the things that the gravity shouldn't be as so powerful that if the player decides to turn directly away from the planet and thrust away, they should be able to get away from the planet. So I just realized that by making the magic circle and doing the screen warping that way, I've actually gone back and harkened back to one of the much older versions of Space War, where it was played on an oscilloscope.
Oh. That's cool.
So I did that for convenience for our purposes, to get this up and going. But the version, the PC version that I showed you, is doing it based on the screen itself, screen coordinates, effectively. Any questions about this assignment? I mean, it's pretty straightforward. It's just there's some little bit of overhead in terms of infrastructure you need to put in. What's up, Jacob?
We don't need to make a specific scene for this lab, do we?
No, you're continuing with this. This lab is a continuation of the previous lab. So if you have not finished lab 7, the first lab, Space War lab, don't worry, get that done, then do this.
Okay.
Question.
Is the laser still going to be in another lab?
It is the lab, lab 9. I split. This was supposed to be the laser was supposed to be part of this lab, but I got to go over some math with you to understand that properly.
Right.
And I understand the algorithm that you need to do, but I don't understand it well enough. I need more time so I can break it down so I can explain it to you.
Right.
Yeah, it's a there's a lot. So basically, what we're doing is we're asking if a line intersects with a sphere, and that actually there's a lot of little bit of pieces of code. There's a lot of little things that you need to do to know whether that's the case. And it really is. There's 3 cases when you ask that. There's 3 cases. Is case 1, does the line is a tangent of the circle, so it touches only one location? Is it going what's called a chord or a secant, which is going through the circle, so it's intersecting on 2. So it's intersecting on 2 points in the circle. Actually, there's 4. The third is line doesn't intersect the circle, but the whole line is inside the circle. So one of the first things we actually do is if one of the points of the line is inside the circle, but we obviously know that we have a collision.
Right.
Yeah. So that's one of the things. And then finally, both points of the line are outside the circle and do not touch the circle at all. So those are essentially our 4 scenarios that we're dealing with. And you can get the third one where the two points, that's pretty simple. That's a simple. That code is pretty straightforward. It's a center circle minus our location. The a b minus a calculation. Magnitude is less than the radius, so that's not that much of an issue. It's the other three that where the code like it, and it's I find implementations and they're good implementations, but they are also not explained. Is the issue? Yet the implementations are like they're using A and B and C and X and Y, and they're not explaining anything in this regards. They take the slope of they do take the slope of they determine the slope of the line, but they don't say that that's what they're doing. So that's why it's its own lab now, because I need more time. Literally, I do need more time to sort that out, so it makes sense what you're doing. If you're still having an issue with the triangle code, point inside of a triangle, I know Carol, you are. Yeah. Submit if that's the only thing you haven't done. Submit what you have, because I got to go back and relook at that lab, because it looks like there's something in that there's things that I probably should have gone over for that lab assignment. I thought there's probably one or two things that I probably should have mentioned and described in better detail before throwing that at you. Before just throwing again, I'm basically saying here's the solution, but didn't explain what the solution's doing and how it's doing it. And that's the thing I'm trying to avoid with. This is why I split it into its own lab, because I want to avoid doing that again. So so if you're still having an issue with point inside of a triangle, come talk to me. Submit what you have, and don't, or if you haven't got to that yet, just skip it, because I need to come back. I need to come back and give you more information. Question.
I have a question, but it's for when you're done recording. Are you done recording?
You should not be asking that while I'm recording.
Okay.
Yeah. Anyone else? Okay, I'm going to stop the recording here.